The oscilloscope is an instrument used to measure voltage. It is especially useful when dealing with a source of alternating current, or AC. In this case, the oscilloscope allows us to track the voltage as a function of time. On the screen of the oscilloscope seen here, the voltage follows a sinusoidal function of time. This video will teach you how to adjust the oscilloscope as well as how to take measurements using this instrument. The signal you want to measure is attached to the oscilloscope using a coaxial cable. You attach it as seen here. The controls on the oscilloscope are divided into two main sections. The vertical section controls the voltage scale. Notice that there can be up to two input sources on this oscilloscope, called A and B. The horizontal section controls the time scale. In the example shown here, only one source is connected in input A. Had there been another voltage source in input B, we could switch what is displayed on the screen by either pressing A or B or both. We can even add the two signals together. Since we only have one source of voltage in this example, let's see how to make the proper scale adjustments on input A. This knob adjusts the vertical position of the signal. In order to make a measurement, we want the signal to be centered. The easiest way to do this is by using the ground line. Setting the switch to GND makes the 0-volt line appear, which we can center on the horizontal axis of the scope. Once this is done, we can return to the AC signal. Next, we will use the dark gray knob to adjust the vertical scale. Use the scale that will give the most precise reading without going outside the screen. Once the scale is chosen, the value indicated by the knob represents one square division on the screen. Here, the height of one square is 1 volt. The horizontal adjustments function in a similar way. The position of the graph can be adjusted and the scales can be changed. Usually, you'll choose a scale that will allow you to view one entire period of the wave. Before reading off the period of the wave, it is useful to adjust the position so that one of the peaks is aligned with the vertical line on the screen. In this case, we're aligning with the central line. Once the horizontal scale is set, the knob indicates the value of one horizontal square on the screen. In this case, each horizontal square is worth 0.2 milliseconds. Each of the controls for the scales contains two independent parts, a light gray knob and a dark gray knob. If you want to change the scale, you must use the dark gray knob. The light gray knob should not be used to set the scale. However, before taking a reading, it is always good to verify that the light gray knob is rotated to its maximum clockwise position. When taking a measurement, you will want to start by centering the signal. First vertically by using the ground line, and then horizontally. You can then adjust the intensity and focus in order to get a sharp line on the screen. Once the ground line is centered, return to the AC signal. Adjust the vertical scale and horizontal scale in order to get the optimal reading. Always make sure the calibration knobs are turned all the way clockwise. A final adjustment to the focus and intensity, and you're ready to take a reading. We're finally ready to take a measurement. This means that we can measure the amplitude and period of the wave. Recall that the value indicated by the knobs refers to the scale on the screen. In the case seen here, each horizontal square is equivalent to 0.2 milliseconds and each vertical square is 1 volt. The amplitude, or delta V max, of this signal is 2 squares plus 2 small divisions. Since in this case each small division is 0.2 volts, the amplitude is 2.4 volts. The period of this signal is 3 horizontal squares and 4 horizontal small divisions. Since each small division is worth 0.04 milliseconds, the period is 0.76 milliseconds.